So we are going to start the topic of calculus again, and under the heading of calculus, we are to do improper integral today. This is improper integral we are going to do. This is also a definite integral. I can give you the example. Suppose we have to discuss about the integration of a to b f of x dx, and it is assumed that the function f is defined. Function f is defined and remains bounded in closed interval ab, and the range of integration is finite. We can take the example of this. Suppose we have to evaluate 1 to 2 x square dx. You can easily find out the value of this. There will be x cube over 3, and you can put the value, that is 8 by 3, and 1 by 3, that is 7 by 3. So this is how you can find out the value of a definite integral. This is already we have done this, but these are said to be proper integral. One more example we can take. Suppose we have 0 to 1 dx over 1 plus x square, and you know that its integration is the tangent inverse x from 0 to 1, and tangent inverse 1 minus tangent inverse 0. Tangent inverse 1, that is pi by 4, and tangent inverse 0 is 0. So ultimately you have the value pi by 4. So we are getting a definite value, or you can say that we are getting a proper value for these integrals, this one and this one. But we may have the cases when we don't have proper value or proper definite value of the integration. Or you can say that we can define improper integrals in more than one way. Suppose the first way is when the upper limit is infinite. This is the first kind of improper integral. This is the first kind of improper integral. The second case is when the lower limit is infinite but upper limit is finite. This is the another case of improper integral. Now, the third case is when we have both limits in terms of infinity, or you can say that integration minus infinity to infinity f of x dx. So this is also improper integral. This is the first case, first kind, second kind of improper integral, and the third kind of improper integral. So we can evaluate the improper integral and can get the values of that. We can take the example also. Suppose we have the example. The question is evaluate integral 1 to infinity x e raised to power minus x dx. Obviously the upper limit is infinite. So this is the improper integral of the first kind or first case. Now, how to find out its integration? You just take limit t approaches to infinity and write down the upper limit in terms of t, so that we can finitely integrate it. And what is the t? T is the upper limit which is greater than lower limit. So t should be greater than 1, because upper limit should always be greater than 1, upper lower limit. So limit t approaches to infinity, integration by parts, first function, second function. First function as it is, integral of second within the limits 1 to t, derivative of first, integration of second within the limits 1 to t. So you can substitute the limits now. That is limit t approaches to infinity. Put the upper limit t here. That is t e raised to power minus t over minus 1. and when you put the lower limit 1, you will get 1 e raised to power minus 1 over minus 1. This is for upper limit and lower limit. Minus and minus will be plus. Integration of e power minus x is e power minus x over minus 1. Now, you just simply put the limits and take the final limit as t approaches to infinity. Because we are getting the expression in terms of t. What is this? This is minus t e raised to power minus t, and this will be plus 1 over e, and this is minus common e raised to power minus t and e inverse. Now, you can take the limits, but before taking the limit, you just simply solve it first. That is the limit t approaches to infinity. You can write down this expression, that is minus t e raised to power t. This is a constant term. You can simply write down 1 over e. This is also the limit t approaches to infinity, 1 over e raised to power t, and this is minus and minus is plus 1 over e. Now, this is t approaches to infinity over t approaches to infinity. This is the term which you will get. E raised to power infinity is infinity. So this is infinity over infinity form. You can find out the derivative by L'Hospital rule. Minus 1 over e raised to power t. This is 2 over e. And this comes out to be 0. Because this denominator will give you infinity. And 1 over infinity is always 0. This is also 0, because minus 1 over infinity will become 0. Ultimately, you are getting a definite value 2 over e for this kind of improper integral in which the upper limit is infinity. Now, you can also take the example when the lower limit is infinity. That is minus infinity to 0. Suppose this is simple, e raised to power 4x. Now you know that we can simply integrate it e power 4x over 4. That is minus infinity to 0. For the upper limit 0, this comes out to be 1. And for the lower limit minus infinity, this will be like this. So 1 over 4. 1 minus 1 over e raised to power infinity. And e raised to power infinity is infinity. And 1 over infinity will give you 0. So ultimately, you will get the definite value 1 by 4. So this is the procedure by which we can integrate. And we can find out the value of the definite integrals. And these definite integrals are improper integrals actually. We can take one more example. Suppose we have to find out the convergence of integration e to infinity dx over x log of x raised to power 3 by 2. And you can name it as capital I, and it can be written in finite t by taking the upper limit t, just like earlier. This is the log of x raised to power minus 3 by 2 into 1 by x into dx. You can write down like this. And you just see, this is the log x, and it is the derivative of log x is 1 over x. But if you remember the formula of fn x into f dash x, this is fx, and its derivative is with this, and its integration is fn plus 1 over n plus 1. This was the formula done in 10 plus 2 class. So by that formula, log x raised to power minus 1 by 2, and this is minus 1 by 2. And you can substitute the limits. The limits are e to t. And in the denominator, we have minus 1 by t, and which will become minus 2. t approaches to infinity. For upper limit t, it is log t raised to power minus 1 by 2. And for lower limit e, log e raised to power minus 1 by 2. And it can this can be solved by doing one more step. This is a minus 2 limit t approaches to infinity. This can be written in the denominator like this, log t raised to power 1 by 2, and similarly that is the log of e raised to power 1 by 2 in the denominator, because in the numerator powers are in negative sign. So it can be taken to the denominator. Now you can substitute the limit. Put t approaches to infinity, log infinity is 0, so 1 over 0, log of infinity is infinity, and 1 over infinity is 0, and this is log e. Log e is always 1, so this is minus 1. Ultimately, minus and minus will be plus. So this is the definite value of the limit, and it is a finite quantity. So this is the procedure by which we can solve and find out the value of a definite improper integral. You can take one more example, 1 to infinity, tangent inverse x over x square dx. Now, you can, because the tangent inverse is involved here, so if you remember the topic of integration done in 10 plus 2 class, the only method is you just need to use a substitution. Put x is equal to tangent of theta, and dx will be secant square theta d theta. And what about the substitution? Tangent inverse into x. Tangent will be gone out. That will be theta, and dx will be secant square theta, and divisible by tangent square theta. So, and what about the limit? When x is equal to 1, theta will be pi by 4. So the lower limit is pi by 4. And when x is equal to infinity, and what about theta limit? You know that tangent theta is infinity. At what angle theta should be? Pi by 2. So this is pi by 2. So the lower limit is pi by 4 and the upper limit is pi by 2, and you can simply integrate it. This was done in 10 plus 2 class. So this is the way to solve improper integrals. Only difference is their limits will be in terms of infinity. This is the difference between proper integral and improper integral. Earlier in the previous class, we have done questions related to proper integrals. But today we are doing the questions related to improper integrals. You may have the question like this also, when both the limits are in terms of infinity. So this is minus infinity to infinity, and this is dx over 1 plus x square. You just apply the rules of integration done in 10 plus 2 class. This come out to be, okay, you can split into two definite integrals. This is the method actually, when both the limits are in terms of infinity. So you can split the limits from minus infinity to 0 and then 0 to infinity. Apply this procedure always for solving the integral when both limits are in terms of infinity. And you know that this is an even function. 1 over 1 plus x square is an even function. So this will become 2 times 0 to infinity dx over 1 plus x square. This is the rule which we have done in 10 plus 2 plus. It becomes twice when the function is even function. If you remember, the rule was like this. minus a to a f of x dx is 2 times 0 to a f of x dx when the function is even function. But when the function is odd function, its value will be 0. 0 value will be there in the case of odd function. Now, you can simply do the upper limit is infinity. So write down the limit in terms of t and integrate it. That will be written like this. That is 2 times limit t approaches to infinity. What is the formula for its integration? That is the tangent inverse x, where the limits 0 to t. Now, substitute the upper limit. For upper limit, tangent inverse t, and for lower limit, tangent inverse 0, and tangent inverse 0 is always 0. Now you can take the limits t approaches to infinity, and tangent inverse infinity will be pi by 2. So ultimate value comes out to be pi. 2 will be cancelled. So this is the procedure to find out the value of definite improper integral when both the limits are in terms of infinity. Lower limit is minus infinity and upper limit is plus infinity. And you just need to break the question. This is the first case, improper integral of, this is the second case actually. Improper integral of second kind, and this is improper integral of first kind. First kind means upper limit infinity. Second kind means lower limit is infinity. So you always break this into two integrals, sum of two integrals, and using the even property, this becomes twice by this rule, and now simply integrate it. So this is the method to apply definite this is the method to find out the value of a definite integrals which are improper. So improper integrals can easily be solved by this method. Now, how this type of integral are different to be solved as we have done in the previous lecture. Only difference is in today's class we have done the questions related to improper integrals. Improper integrals mean when one of the limit or both of the limits are in terms of infinity. This is the only difference. Otherwise, this is also a definite integral. So, any question you want to ask? Any question?
No, sir.
माइक्रोफोन ऑन करिए सभी लोग. एक बात बस नोट करने वाली है, ये भी डेफिनेट इंटीग्रल है. जो हमने पिछले लेक्चर में करे वो भी डेफिनेट इंटीग्रल थे, और जो आपने 10+2 में करे वो भी डेफिनेट इंटीग्रल ही थे. तो आपने +2 वाला मेथड ही, ये +2 वाले इंटीग्रल ही हैं. बस +2 में प्रोबेबली +2 में आपने इंफिनिटी में करे थे इंटीग्रल्स.
यस सर, कुछ क्वेश्चन सर.